Very good morning, dear children. Today we are going to see the fifth unit, electricity. Before we start lesson, we shall say the prayer. God grant me the serenity to accept the things I cannot change, courage to change the things I can, and the wisdom to know the difference. Amen. Dear children, today we are going to see the lesson electricity. This is a very important lesson which is going to be continued till your 12th standard. So let's learn the basics about the electricity in your 8th standard and learn it very sincerely. All things we use in our life are made up of elements. Each element is made up of atoms, which is the smallest unit. John Dalton, the scientist, considered that atoms cannot be divided further, but it was found out later through Rutherford's gold foil experiment that atoms are made up of particles like proton, electron and neutron. Movement of electron in a material constitutes electric current and generates an electrical energy called electricity. We use this energy in our life for various needs. Electric bulb, fans, electric iron box, washing machine and refrigerator are some of the appliances which work with the help of electricity. So in this lesson, we will study about electric charges and how they are transferred. This lesson will also cover electric circuit and the effect of electric current. Let's see the basics about atom. An atom consists of proton, electron and neutron, which are called subatomic particles. Proton and neutrons are found inside the nucleus, which is at the center of the atom. Electrons revolve around the nucleus in different paths, and the paths are known as orbits. In an atom, the number of protons and the number of electrons will always be equal. There is a force of attraction between the proton in the nucleus and the electron in the orbit. The electrons in the inner orbit are strongly attracted by the proton. So what are the inner orbit electron? So this is the innermost orbit and this is innermost orbit. This is next. This is the outermost orbit. So electrons in the outermost orbits are loosely bounded. So it can be removed from the atoms easily. The innermost electron cannot be removed easily because the outermost orbits are loosely bound and they can be easily removed from the atom. Okay. So next we need to see about charges. Charge or electric charge is the basic property of matter that causes objects to attract or repel each other. It is carried by subatomic particles like protons and electrons. Charges can neither be created nor be destroyed. These are all the fundamental properties of electric charges. Okay. And there are two types of charges. One is positive charge, another one is negative charge. So positive charge is proton, which carries positive charge, and the electrons carries the negative charge. There is a force of attraction or repulsion between the charges. So like charges always repel. See, plus and plus. This is plus, this is plus. So they repel each other. So the arrow mark shows the repulsive force. Okay, negative, minus, minus. So it repels. Here minus and plus, opposite charges. These opposite charges attract each other. So the inward arrow mark shows you the attractive force. So outward arrow mark shows you the repulsive force and inward arrow mark shows you the attractive force. Electric charge is measured in coulomb. C is the unit for electric charge. Small amount of charge that can exist freely is called elementary charge, that is E. Its value is 1.602 in 10 to the power minus 19 coulomb. This is the amount of charge possessed by each proton and electron, but the proton have positive elementary charge E plus and the electron have negative elementary charge E minus. Since proton and electron are equal in number, an atom is electrically neutral. So then what happens when the electric current passes? So that we need to know about transfer of charges. As we saw earlier, electrons in the outermost orbit of an atom can be easily removed. They can be transferred from one substance to another substance. The substance which gain electron becomes negatively charged and the substance which loses electron will become positively charged. Gain means negative charge, loses means positively charged. Transfer of charges takes place in the following way. There are three ways. One is transfer of friction, transfer by conduction, transfer by induction. Let's see three types one by one. First, transfer by friction. It's a very common thing. This transfer by friction results in electrostatic forces. Comb rubbed with hair you take a comb and place it near some pieces of paper. Are they attracted by the comb? You can you cannot see any attractive force between the comb and the pieces of paper. Next, what you have to do, you comb a dry hair again and again frequently, very fast, and place that comb near the pieces of paper. What you will see, you can see the paper pieces are attracted by the comb now. How is it possible? Comb rubbed with hair gain electrons from the hair and becomes negatively charged. These electrons are accumulated on the surface of the comb. When a piece of paper is teared into bits, positive and negative charges are present at the edges of the bit. Negative charges in the comb attracts the positive charge in the bit, so the paper bit are moved towards the comb. While combing hair, charges are transferred from the hair to comb due to friction. If the hair is wet, the friction between the hair and the comb reduced, which will reduce the number of electrons transferred from the hair to comb. Hence, rubbing certain materials with one another can cause a build-up of electric charges on the surface. From this, it is clear that charges are transferred by friction. A similar effect can be seen when you rub the few other materials with one another. When a glass rod is rubbed with a silk cloth, what will happen? The silk cloth, the free electrons in the glass rod are transferred to the silk cloth. It is because the free electrons in the glass rod are less tightly bound as compared to that in the silk cloth. Since the glass rod loses electron, it has a deficiency of electron and hence acquired positive charge. But in the silk cloth has excess of electron, so it becomes negatively charged. Same thing is happened with ebonite rod with the fur. When an ebonite rod made up of valusinized rubber. It is rubbed with fur. The fur transfers electron to the ebonite rod because the electrons in the outermost orbit of the atoms in fur are loosely bound as compared to the ebonite rod. The ebonite rod which has excess electron become negatively charged and the fur which has deficiency of electron is positively charged. From these we come to know that when two materials are rubbed together, some electrons may be transferred from one material to the other, leaving them both with a net electric charge. When the ebonite rod is rubbed with the woolen cloth, electrons from the woolen cloth are transferred to the ebonite rod. Now the ebonite rod will be negatively charged. When it is brought near the paper cylinder, negative charges in the rod are attracted by the positive charges in the cylinder. When the cylinder is touched by the rod, some negative charges are transferred to the paper. Hence, the negative charges in the rod are repelled by the negative charges in the cylinder. Thus, we can say that charges can be transferred to the object by bringing it in contact with the charged body. This method of transferring charges from one body to the other is called as transfer by conduction. The material which allows electric charge to pass through them easily are called conductors of electricity. For example, metals like aluminum, copper are good conductors of electricity. Materials which do not allow electric charge to pass through them easily are called insulators. Rubbers, wood and plastics are insulators. Next, the second type, transfer by induction. We saw that we can charge an uncharged object when we touch it by a charged object. But even we didn't touch, there will be a possibility for charges to create. But it is also possible to obtain charges in a body without any contact with other charged body. The process of charging an uncharged body by bringing a charged body near to it but without touching it is called induction. The uncharged body acquires an opposite charge at the near end and the similar charges at the further end. Similarly, when a positively charged rod is, see the activity, this is the explanation for the activity. You see the activity and listen to my explanation. When a positively charged rod is brought near an uncharged rod, negatively charged electrons are attracted towards it. As a result, there is excess of electron at nearer end and deficiency of electron at the further end. The nearer end of the uncharged rod become negatively charged and far end is positively charged. Now the third type, flow of charges. Suppose you have two metallic spheres, one having more negative charge, excess of electrons, and the other having more positive charge, deficiency of electron. When you connect them both with the help of a metallic wire, excess of electrons from the negatively charged sphere will start flowing towards the positively charged sphere. This flow continues till the number of electrons in both the sphere is equal. This is similar to water current. Here the positively charged sphere is said to be at the higher potential and the negatively charged sphere is said to be at the lower potential. Hence, electrons flow from lower potential to higher potential. This is known electric current, that is flow of current. The difference between these potential is known as potential difference, commonly known as voltage. Before the discovery of electrons, it was considered that electric current is due to the flow of positive charge. Flow of positive charge is called conventional current. Conventional current flows from higher potential to the lower potential. Next, we need to see about a device named electroscope. An electroscope is a scientific instrument used to detect the presence of electric charge on a body. In the year 16th century, 1600, British physician William Gilbert invented the first electroscope. It is the first electrical instrument. There are two types of electroscope. One is pith boy electroscope, another one is gold leaf electroscope. An electroscope is made out of conducting materials, generally metals. It works on the principle that like charges repel each other. In a simple electroscopes, two metal sheets are hung in contact with each other. They are connected to a metal rod that extends upward and end in a knob at the end. If you bring charged object near the knob, electrons will either move out of it or into it. This will result in charges accumulating on the metal leaves inside the electroscope. If a negatively charged object is brought near the top knob of the electroscope, it causes free electron in the electroscope to move down into the leaves, leaving the top positive. Since both the leaves have negative charges, they repel each other and move apart. If a positive object is brought near the top knob of the electroscope, the the free electrons in the electroscope start to move up towards the knob. This means that the bottom has a net positive charge. The leaves will spread apart again now. Gold leaf electroscope. The gold leaf electroscope was developed in 1787 by a British scientist named Abraham Bennett. Gold and silver are used in the electroscope because they are the best conductor of electric current. What is the structure of electroscope? Gold leaf electroscope. It is made up of a glass jar. A vertical brass rod is inserted into the jar through a cork. The top of the brass rod has a horizontal brass rod or a brass disc. Two gold leaves are suspended from the brass rod inside the jar. Working of the electroscope. When the brass disc of the electroscope is touched by a charged object, electric charges get transferred to the gold leaf through the rod. This results in the gold leaves moving away from each other. This happens because both the leaves have similar charges. How it is charging? Transfer of charge from one object to another is called charging. In case of gold leaves, charge is transferred through the brass rod. Electrical discharge. The gold leaves resume their normal position after some time. This happens because they lose their charge. This process is called electrical discharge. The gold leaf would also be discharged when someone touched the brass rod with their bare hands. In that case, the charge is transferred to the earth through the human body. Next, we need to see about lightning and thunder. How the lightning is produced? Lightning is produced by discharge of electricity from cloud to cloud or from cloud to ground. During thunderstorm, air is moving upward rapidly. This air, which moves rapidly, carries small ice crystals upward. At the same time, small water drops move downward. When they collide, ice crystal become positively charged and move upward, and the water drops become negatively charged and move downward. So the upper part of the cloud is positively charged and the lower part of the cloud is negatively charged. When they come into contact, electrons in the water drops are attracted by the positive charges in the ice crystal. Thus, electricity is generated and the lightning is seen. Sometimes lightning may be seen before the thunder is heard. This is because the distance between the cloud and the surface is very long and the speed of light is more than the speed of the sound. That's why you see the lightning first, later you hear the thunder. Next, the important process known earthing is explained. Let's see what is earthing. In our home, we can see on home appliances, you can see earthing pin. Earthing will happen. What is earthing? A safety measure device to prevent people from getting shocked if the insulation inside electrical device fails is called earthing. Electrical earthing can be defined as the process of transferring the discharge of electric energy directly to the earth with the help of low resistance wire. We get electrical energy from different sources. Battery is one such source. We use it in wall clocks, cell phones, etc. For the working of refrigerator, air conditioner, washing machine, television, laptop and water heater, we use domestic power supply. Usually an electric appliance such as heater and iron box etc. are fitted with three wires, namely live, neutral and earth. The earth wire is connected to the metallic body of the appliance. This is done to avoid accidental shock. Suppose due to some defect, the insulation of the live wire inside an electric iron is burnt. Then the live wire may touch the metallic body of the iron. If the earth wire is properly connected to the metallic body, current will pass into the earth through the earth wire and it will protect us from the electric shock. This is why the earthening is given in many appliances. The earth, being a good conductor of electricity, acts as a conventional path for the flow of electric current that leaks out from the insulation. Next, we are going to see lightning arrestor. In large, huge buildings, lightning arresters are placed at the top of the building. Why it is placed? Let's see the explanation. Lightning arrestor is a device used to protect the buildings from the effect of lightning. Lightning conductor consists of a metallic lightning rod that remains in the air at the top of the at the top of the rod at the top of the building. A major portion of the metal rod and the copper cable are insulated in the walls during its construction. The other end of the rod is placed deep into the soil. When lightning falls, it is attracted by the metal rods at the top of the building. The rod provides easy routes for the transfer of electric charge to the ground. In the absence of lightning arrestor, lightning will fall on the building and the building will be damaged. That's why in large buildings, lightning arresters placed at the top. Okay. Next, we are going to see about vast thing, electric circuit. Here in 8th standard, they have given the basic things only. So, if you are strong in the basic, you can develop your knowledge in the field of electricity in the later classes, later standards. So, it will be very interesting and useful. Let's see that. We see that when two oppositely charged spheres are connected by a metal wire, electrons flow from the sphere which is at lower potential to the sphere at higher potential. Similarly, if two terminals of a battery which are at different potential are connected by a metallic wire, electrons will flow from negative terminal to the positive terminal. The path which electrons flow from one terminal to another terminal of the source is called electric circuit. A simple circuit consists of four elements: a source of electricity, a path, the path or a conductor through which electricity flow, a switch to control the circuit, and an electric resistor, which is any device that requires electricity to operate. So here they have given you a simple electric circuit, a switch, bulb and a battery. And the above figure shows a simple circuit containing a battery, two wires, key and an electric bulb. The source can be battery or the electric outlet in your room. The electrical resistor refers to the device, that is nothing but the bulb, that consumes the energy. Control is key, is a mechanism that is used to start, stop and regulate the electric current. When the key is on, electrons from the battery flow through the circuit from the negative terminal to the wire conductor, then through the bulb and finally back to the positive terminal of the battery. The light glows when current is flowing through its filament. There are two basic ways in which we can connect these components. They are series and parallel. What is series circuit? A series circuit is one that has more than one resistor. Resistor here is bulb, okay, any electric device, but only one path through which the electron can travel. From one end of the battery to the battery, the electrons move along the one path which with no branches through the resistors to the other end of the cell. All the components in a series circuit are connected end to end, so current through the circuit remains same throughout the circuit, but the voltage gets divided across the bulb and the circuit. In the following series circuit, two bulbs are used as resistor. In this series circuit, charges are electrons from the battery have only one path to travel. Here battery, key and two bulbs are connected in series. Charges flow from the battery to each bulb one at a time. In the order, they are wired to the circuit. If one bulb is in the circuit is unscrewed, the current flow to another bulb would be interrupted. This is what happen in the series circuit. We put serial light during festivals. Yes, and this is a Christmas season. Many of you may put serial light in your home. If the lights are in a series circuit, one burnt out bulb will keep all the lights off. If the number of bulbs in a circuit with a battery increases, the lights will be dimmer because many resistors are acting on the same power from the battery. We saw that in series circuit, same current travels through every resistance and the voltage will be different across each resistance. Let us consider three bulbs connected in series. Let I be the current through the circuit and V1, V2, V3 be the voltages across the each bulb. The supply voltage V is the total voltage of the individual voltage drop across all the three resistors. Therefore, V is equal to V1 plus V2 plus V3. Next, we need to see about parallel circuit. In a parallel circuit, there is more than one resistor and they are connected on many paths. This means charges can travel from one end of the cell through many branches to the other end of the cell. Here voltage across the resistor remains the same, but the current flowing through the circuit gets divided. In the previous case, in series case, current is same, voltage is divided. In the parallel circuit, current is divided, current flowing through the circuit gets divided, but the voltage is same. Here if one resistor is out of work, means it will not interrupt the flow of current and it will flow through the another bulb and it will burn. Okay. So what is I? I is equal to I1 plus I2 plus I3. So difference between series and parallel circuit is given in your textbook. Let's see that. Same amount of current flows through all the component in series circuit. The current flowing through each component combine to form the current flow in the parallel circuit. Voltage is different across the different components for series circuit. Sum of the through each component will be the voltage drawn from the sources. In series circuit, components are arranged in a line. In parallel circuit, components are arranged parallel to each other. If one component breaks down, the whole circuit will be burn out in a series circuit. Other components will function even if one component breaks down in a parallel circuit. What are the effects of current? We not only produce electricity or lighting due to current, we also obtain many things using current. We use iron box. What is that? Heating effect of current. We uses some gold plated ornaments. What is that? It is electroplating. That is a chemical effect of current. There are lot of effects of current. Here in your 8th standard they have given only two effects of current. One is chemical effect, another one is heating effect of current. Let's first see the chemical effect of current. What is the chemical effect of current? There will be an electrolyte. If you pass current through that electrolyte will separate into positive and negative ions. So it will be used in many cases in your day-to-day life. Let's see in detail. We know the electricity is conducted by metals. This activity shows the liquid also conduct electricity. You must know liquid also conduct electricity, because in ordinary water, if the electric wire falls on the ordinary water, it conduct electricity and it passes through the human being or animals, living organisms, which passes through and passes electricity towards us. Okay, it is a harmful effect. So liquids can also conduct electricity. That is the basic thing you must remember always. When electric current is passed through a conducting solution, some chemical reactions takes place in the solution. This chemical reaction produces electrons which conduct electricity. This is called chemical effect of electric current. The decomposition of molecules of a solution into positive and negative ions on passing an electric current through it is called electrolysis. Electrolysis has a number of applications. It is used in extraction and purification of metal. The most general use of electrolyte is electroplating. Now let's see what is electroplating. Electroplating is one of the most common application of chemical effect of electric current. The process of depositing a layer of one metal over the surface of another metal by passing electric current is called as electroplating. Gold like ornaments we are wearing, no? Inside it is not gold, but outer layer seems like a gold. That is electroplating. The bangles, earrings, ornaments, etc. Okay, electroplating is applied in many fields. We use iron in bridges and automobiles to provide strength. However, iron tends to corrode, turupidiko, and rust. So a coating of zinc is deposited on iron to protect it from corrosion and formation of rust. Chromium has a shiny appearance. It does not corrode. It resists structures, but chromium is expensive and it may not be economical to make the whole object out of chromium. So what they decide? So the objects such as car part, bathtubs, kitchen gas burners, bicycle hand levers, wheel rims are made up of cheaper metal and only a coating of chromium is deposited over it. And the silver color la pala pala, that is coating of chromium. Okay, it is inside, it is made up of iron, outer layer is chromium. That happens in the process known as electroplating. Next we are going to see the heating effect of current. When electric current passes through a conductor, there is a considerable friction between the moving electrons and the molecules of the conductor. During this process, electric energy is transferred to heat energy. This is known as heating effect of electric current. The heat produced depends on the amount of resistance offered by the wire. Copper wire offers very little resistance and does not get heated up quickly. So it is used in our all our electric connecting wires. Okay, on the other hand, thin wires of tungsten or nichrome, which are used in bulbs, offer high resistance and gets heated up quickly. The reason why tungsten wire is used in the filament of the bulb and nichrome wire is used as a heating element in household heating appliances, because its resistance is high. Heating effect of electric current can be seen in many devices. Some of them are given below. Fuse, very basic thing. Fuse. What is fuse? Fuse is a strip of alloy wire which is made up of lead and tin with a very low melting point. This can be connected to the circuit. The fuse is usually designed to take specific amount of current. When current passing through the wire exceeds the maximum limit, it gets heated up. Due to low melting point, it melts quickly, disconnecting the circuit. This prevents the damages of the appliances at our home. So fuse is very much important at home. Next we need to see electric cooker. Electric cookers turns red hot when electric current is passed through the coil. The heat energy produced is absorbed by the cooking pot through conduction. Electric kettles. The heating element is placed at the bottom of the kettle which contains water. The heat is then absorbed by the liquid and distributed throughout the liquid by convection. Next, electric ions. When current flows through the heating element, the heat energy developed is conducted to the heavy metal base, raising the temperature. This energy is then used to press clothes. So, I hope you all understand this lesson very clearly. I wish you all the best. God bless you. Learn well. Thank you, girls.